Welcome, welcome. Don't know why my camera. There we go. Welcome, y'all. What is going on? Happy Wednesday, everybody. Hope your week is going well. Um, we are back. We are live. We are healthy. So, a couple more things I can ask for, but we'll go with that for now. But thanks for joining. We are. Let me know if the volume is okay. If you're watching, let me know if you're getting this well. We are live at the Alpha Esports and Technology Center, which as you can see, is a little different than the cave. So we are here at my gaming and technology center here in Suwanee, Georgia. For those who don't know, let me just do this real quick to show some stuff. So we have our setup over here, and then we have our PCs. Watching a little bit of League of Legends, and we are back on the main stage with me. So again, thank you for joining. Let me bring this down a little bit. And wanted to continue on our journey with AWS Cloud Quest. Thank you for the support and for the comments that I've been receiving. A lot of people found it helpful. A lot of people found the Q&A stuff to be helpful. So wanted to kind of keep it going. Like I said on the other day, we started the AWS Cloud Quest. For one, because I need to recertify my AWS Cloud Practitioner certification, and two, wanted to highlight the gamification of gaming, the gamification of education. So gaming and technology coming together for a good cause, which is what we do here at Alpha Esports and Technology. So I figured, why not showcase that, just like I would showcase any of my gaming stuff. So, so we're going to get to the Cloud Practitioner Cloud Quest shortly, but just wanted to stop in and say hello. Again, thanks everybody for who support the stream. If you haven't done so already, please go ahead and click like the page wherever it is you're watching, because we are streaming live on multiple platforms. I think we are streaming on our Alpha Cybersecurity as well as our Alpha Esports and Technology pages. So that is our YouTube page as well as our Twitch pages. And then we're also on LinkedIn on my personal page, Davin Jackson. How you doing? And as well as our Facebook page for Alpha Esports and Technology. So if you're wherever you're watching, please be sure to like that platform. If you want to go ahead and like the other channels, please do so there as well. You can see the ticker below. These are the different areas you can like, follow, and subscribe. Click the bell for notifications, and also tell a friend to tell a friend. We want to get that algorithm up. Also, if you want to support the stream, you can do so in many ways. You can do so by one, like I said, just liking, following, commenting, sharing, subscribing, or you can click up here, that QR code that you see here in the corner, that you can use that to buy me a coffee. It's $5. Or if you're on our YouTube channel, like our Alpha Cybersecurity YouTube channel, you can also do super chats or anything like that. They are not mandatory, they are not necessary, but they are greatly appreciated, as everything we do goes back to building out content and supporting this amazing center and this community that we're building here. So again, we are live from the Alpha Esports Technology Center here in Suwanee, Georgia. 3109 Peachtree Industrial, I'm sorry, not 3109, 1300 Peachtree Industrial Boulevard, Suite 3109 here in Suwanee, Georgia. All right, so we got that out the way. Let's go ahead and get into our AWS Cloud Quest. So we will switch screens here, and I will put myself here on the bottom. How you doing? You see we got a little bit of music playing right now, only because the last time we were on, we got a copyright notice, I guess, about the music from AWS. So we're going to go ahead and turn that down. And again, we have the music playing from Restream, just to make sure that we don't get in any more trouble. Okay, so I'll turn the volume on when we watch some of the videos. And like I said, just be sure to, leave your questions in the chat like we've been doing all week. And let's get started. So everybody who's in so far, thanks for joining. Thanks for supporting the stream. Again, we are live at the Alpha Esports and Technology Center, and we are starting day 2 of our AWS Cloud Quest. So we started the first mission, and we completed that the other day by completing the S3 buckets. We learned about AWS's S3 buckets and how you can build static websites with them. And then we went ahead and did the exercise. So now we are going to continue on with level 2. Here's some stuff about the escape room and other challenges that they have going on. Let's see what we have here. Cloud first steps. And we're going to go ahead and just click the route to head over to our next mission. So let's go ahead and click that. And we have our avatar here who's dressed dapper. Remember, we're CEOs and executives now, even though I got my Only Hacks t-shirt on. But we are going to, we're dressing for success. So here we are in our cloud aisle, and we are meeting with someone else. And it says here, "Hi, I'm sorry our encounter is during an emergency, but we have a major issue to deal with." We go ahead, no problem. City stabilization system is malfunctioning. Okay, the computational module in our stabilization system is controlled by a physical server, and yesterday the hard disk started to show signs of failing. I ordered a new hard drive, but it will arrive in 48 hours, which might be too late. Stabilization system problems are causing tremors on the island. What would you recommend? So I think they're going to talk about some type of failover device or how you can clone your AWS instances to make sure you have failovers and redundancy. But let's see what they say. Oh, I think we can use an Amazon EC2 to solve this problem. Okay, so EC2 is the Elastic Compute Cloud, or EC2, which is a web service that provides reliable, scalable compute capacity in the cloud so you can launch virtual servers in minutes. So remember, we talked about that the other day. We talked about the scalability of cloud environments, the fact that you can spin up and tear down servers in minutes, and it saves a lot of money rather than building a physical server that you would have to put on premises. With a cloud server, you can build it up, spin it up as you need, and then as the requirements become less and less, you can actually take down that server. Whereas if you purchase a server, you're gonna have to provision it, configure it, set it up, get it to communicate and play nice with everything else on the network. And then if you have any downtime, you're going to be stuck with that server. This one, like I said, with scalability, you can bring it up when you need it, take it down when you don't need it, and save some money in the process. Okay, so it says, that sounds promising. Can you tell me more about the server resilience? So they say, as you mentioned, devices can fail at any time. To help improve server resilience, you can use AWS infrastructure to place EC2 servers into 2 availability zones. So again, this is what I was talking about, failovers. Okay, so availability zones, which we talked about also the other day, they're basically there are different availability zones and centers in different regions, and that also gives you that redundancy and basically like a backup. Okay, so availability zone, or AZ's logical center in an AWS region that has redundant and separate power, networking, and connectivity. Each availability zone is supported by 1 or more physical data centers. Okay, so they're talking about this is resilient. AWS is reliable. You can deploy the solution and get the island back running. Okay, so we're going to go ahead and get started. So we'll head and we'll accept the mission. And now we will turn down our music and turn up our sound so that we can hear the videos that we're about to watch. All right, so again, if you have any comments or you want to chat while we're going through this, feel free. If you have any questions for me, my opinion, whatever, just shoot it here in the chat and we can chop it up for a little bit. All right, so the first step says we're going to create an Amazon EC2 instance to run the computational models for the island stabilization system. Each instance should be placed in a different availability zone in the same region. Okay, so it says the island improves the reliability and availability of a stabilization system by moving the computational module to the global infrastructure. And then this goes into the global infrastructure overview. Here you can see this is the stabilization system. This would be one availability zone. So you can see this is US East -1A. And then you have the second availability zone, which is B for computational model B. And that's going to be in US East 1B. So here's your stabilization system. And then you have your different servers in different regions for the availability zone. All right, so let's go ahead and
AWS Global Infrastructure Overview. The AWS Global Infrastructure delivers a cloud infrastructure companies can depend on, no matter their size, changing needs, or challenges. It is designed and built to deliver the most flexible, reliable, scalable, and secure cloud computing environment with the highest quality global network performance available today. AWS provides the most extensive global footprint to ensure your worldwide customers are served. You can rapidly expand operations to virtually any region or country. AWS now spans 69 availability zones within 22 geographic regions around the world. The footprint is expanding continuously, with plans for 13 more availability zones and 4 more AWS regions in Indonesia, Italy, South Africa, and Spain. This fast-paced expansion of region is also paired with Amazon's long-term commitment to a sustained future using renewable energy sources. The AWS global infrastructure consists of the following main components. Amazon Cloud Computing resources are hosted in multiple worldwide locations, referred as AWS regions. Each AWS region is a separate geographic area and has multiple, isolated locations known as availability zones. A AWS region has at least 2 availability zones, most have 3, including all new regions, and several have as many as 6. They are fully isolated and are many kilometers apart from each other for complete redundancy. Each availability zone consists of 1 or more discrete data centers, typically 3, and at full scale can be hundreds of thousands of servers.
Getting used to this stuff.
To ensure maximum reliability, each data center has redundant power, dedicated metro fiber connectivity, and housed in separate facilities. Network. Every data center, AZ and AWS region is interconnected via a purpose-built, highly available, and low-latency private global network infrastructure. The network is built on a global, fully redundant, parallel 100 gigabit Ethernet metro fiber network. Points of presence. With Amazon CloudFront, AWS operates the largest global content delivery network, CDN, of any cloud provider. It enables customers to securely deliver customers' data content to end users with lower latency and high transfer speeds through a worldwide network of global points of presence, POP, locations, which consists of edge locations and regional edge cache servers.
Okay. So
availability zones make partitioning applications as easy as it can be. If an application is partitioned across availability zones, companies are better protected from natural disasters, such as lightning strikes, tornadoes, earthquake, and more. In this example, you can deploy your application across 3 availability zones, and a load balancer is used to distribute traffic across them. If one availability zone experiences an outage, traffic is routed to other availability zones. Customer application is still up and running.
Who's on their way to a golden road. Perks takes him down. It was also that was a huge.
So I think they need to work on their voiceover AI model, but other than that, like I said, we looked at some of this the other day. So we talked about the global infrastructure, their components. We talked about how they have the regions, which are just basically locations all over the world that are completely isolated from one another. So they have their own independent facilities that have their own power, own network. Again, just to make sure that if in the event of any type of failure, that each data center each data center is still able to work and communicate independently of others in the event of any type of emergency. So that's what they're talking about here with with the availability zones, and then the data centers are in the availability zones, and then you have the point of presences that focus on that. And then, like I said, they have their own internet, 100 gigabit Ethernet on a fiber network, and again, that just makes sure that everything is running smoothly. So you have that, and then you have your high availability applications, and as well as, again, going into the global infrastructure of the regions and the availability zones. All right, so we'll just go ahead and jump into
AWS Global Infrastructure Benefits. Here are the benefits of the AWS Global Infrastructure. Performance. AWS Global Infrastructure ensures high quality and uninterrupted performance. It offers customers a high-performing, low-latency, highly scalable, high-availability, secure cloud infrastructure and responds to changing needs fast without any drop in performance. AWS provides customers with the highest levels of availability and reliability. AWS availability zones are designed for physical redundancy and provide resilience, enabling uninterrupted performance with no single points of failure. Every component of the AWS infrastructure is designed and built for redundancy and reliability, from regions to networking links to load balancers to routers and firmware. In addition, the AWS Global Infrastructure is built on Amazon's own custom hardware, such as custom purpose-built compute servers, load balancers, routers, and silicon. AWS optimizes this hardware for only one set of requirements: workloads run by AWS customers. By using custom hardware, AWS provides customers with the highest levels of reliability, the fastest pace of innovation, all at the lowest possible cost. Security. Our core infrastructure is designed to meet the most stringent security requirements in the world and is built to satisfy the security requirements for military, global banks, and other high-sensitivity organizations. Our infrastructure is monitored 24/7 to help ensure the confidentiality, integrity, and availability of our customers' data. Scalability. The AWS Global Infrastructure enables companies to be extremely flexible and take advantage of the conceptually infinite scalability of the cloud. Customers can provision the amount of resources that they actually need, knowing they can instantly scale up or down along with the needs of their business. Companies can quickly spin up resources as they need them, deploying hundreds or even thousands of servers in minutes. Low cost. With the industry's most extensive data center footprint, the AWS Global Infrastructure enables more customers to benefit from cloud economics of scale and reduce the total cost of ownership, TCO, of their overall IT infrastructure.
Okay, so we're going to
Amazon Elastic Compute Cloud Overview. Amazon Elastic Compute Cloud, or EC2, is a web service that provides secure, resizable compute capacity in the cloud. It eliminates your need for upfront hardware investment so you can develop and deploy applications faster. You can use Amazon EC2 to launch as many, or as few virtual servers as you need. Amazon EC2 enables you to scale up or down within minutes to handle changes or spikes in requirements, reducing your need to forecast traffic. It provides you with complete control of your computing resources and lets you run on Amazon's proven, reliable, and scalable computing environment. Amazon EC2 is hosted in multiple locations worldwide, comprised of AWS regions, which consists of at least 3 availability zones. This computing environment provides high availability, with service level agreement, SLA, commitment, of 99.99% availability for each Amazon EC2 region. In addition, security at AWS is our top priority. AWS is built to meet the requirements of the most security-sensitive organizations. First, let's go through some of the Amazon EC2 basics. What is an instance? An instance is a virtual server in the cloud. Amazon EC2 provides a wide selection of instance types to enable you to choose the CPU, memory, storage, networking capacity, and GPU for your applications. Here are the instance type categories. General purpose instances are instances that provide a balance of compute, memory, and networking resources. Compute optimized instances are optimized for compute-intensive workloads. Memory optimized instances. These instances are for memory-intensive workloads that process large data sets in memory. Storage optimized instances. They are designed for workloads that require sequential read and write access to very large data sets on local storage. Accelerated computing instances. These are GPU instances that use hardware accelerators. HPC optimized instances. These instances are optimized for high-performance computing workloads. These instance types are optimized to fit different use cases. Here is just one of the many examples for each instance types. In addition, each instance type includes one or more instance sizes, allowing you to scale your resources to the requirements of your target workload. AMI. AMI stands for Amazon Machine Image. An AMI provides the information required to launch an instance. It is a template that contains a software configuration such as an operating system, applications, and an application server. You must specify an AMI when you launch an instance. You can launch a single instance or multiple instances from an AMI.
So, just if you've ever built a virtual machine before, think of Amazon Elastic Compute Cloud like setting up a VM. Okay, so you're when you build a VM, you're using a computer within a computer. Well, what AWS or any cloud platform, what they do with their instances is you're essentially just using their computer to build your virtual environment. So same thing with the EC2 stuff. You would find your virtual server, and you would use the different components you need. So you would add your how much RAM you need, how much hard drive space you would need, what CPU, how many CPUs you need for processing power. You would add all that information, and then again, so that depends on what you use, right? So, for example, as a pen tester, I need a beefy system to be able to handle what I do and basically run Kali Linux. So I would create a virtual machine, or in this case, an EC2 instance that would be able to handle what I need for as a pen tester. Here you go. It goes into the different types. You can do general purpose. There's optimize, memory optimized, storage, accelerated computing, and HPC. And then you even have some, like I think NVIDIA is doing their own type where you can actually basically create gaming machines in the cloud. So you can use their GPUs, right? So if you can't afford to buy, a gaming PC with like an RTX, 4090 or something in there, you can rent their services, right? As a matter of fact, let me see. But that's kind of the concept behind it, right? It's just using the processing power of other systems over the cloud or over the internet. So I'm trying to see if I can bring up GeForce Now. So for example, here's GeForce Now, right? So basically you're using their cloud environment to play games on their servers. And on their servers, they have their high-end graphics cards, right? So we'll just say not now. So for example, you can have a basic rig for free. You can play for an hour. There's ads involved. Or for a monthly program, you can use these. You can use these programs here. As a matter of fact, I mean, they're not about $100 for 6 months, 8-hour sessions, 4K resolution. I mean, this might be ideal if again, I'm a gaming center, right? So this might be ideal. Like if I need to do a tournament and I don't want to lug all of the equipment, I can buy. I can use their cloud environment. You just need to make sure that you have good enough internet to be able to handle it. So anyway, back to our regularly scheduled program before we get off script here. So we did the overview. Now let's just look at their storage.
Amazon
networking.
Elastic Compute Cloud EC2 overview. Storage and networking. Amazon EC2 provides you with flexible, cost-effective, and easy-to-use data storage options for your instances. Instances can access storage from disks that are physically attached to the host computer. This disk storage is referred as Instance Store, which provides temporary block-level storage for your instance. You can also attach an Amazon Elastic Block Store, Amazon EBS volume to your EC2 instance for persistent block-level storage. EBS behaves like a raw, unformatted, external block device. Your EBS data can be backed up using EBS snapshots and stored in Amazon S3. Amazon EC2 also uses Amazon S3 for storing Amazon Machine Images, or AMIs. In addition, you can also create a file system for use with Amazon EC2. Amazon Elastic File System, EFS, provides scalable file storage. Applications running on your EC2 instances can access your file system at the same time. Networking defines your network access to your EC2 instances. Amazon Virtual Private Cloud, VPC, lets you provision a logically isolated area within the AWS Cloud, where you can launch your EC2 instances in a virtual network that you define. Alternatively, your AWS account comes with a pre-configured default VPC in each region. You can launch your EC2 instances into the default VPC right away. A VPC can also span multiple availability zones, AZs, in a region. You can add subnets in different AZs and launch instances into the subnets to improve fault tolerance in your applications. You can also use multiple layers of security to help control access to Amazon EC2 instances in each subnet. For example, you can define a security group, which acts as a virtual firewall that controls the traffic for your instances. Now, let's look at how these EC2 basic concepts are used to launch Amazon EC2 instances. To launch Amazon EC2 instances, first, you need to determine whether you want to run your Amazon EC2 instances in a single location or multiple locations, regions, availability zones. Select an Amazon machine image. Then determine which Amazon EC2 instance types and sizes you want. You will also need to configure network access and specify any preferred subnet on your Amazon EC2 instances.
What's up, Ty?
A default root storage is used to boot the instance. You can edit the root volume or attach additional storage to your instances. As an option, you can add tags to your instances. Tags are used to categorize your resources and help in searching and managing your resources. Configure security on your Amazon EC2 instances, such as configure security groups. You can also secure your login information for your instances, using key pairs, public and private key. With these simple steps, you can use Amazon EC2 to launch as many or as few instances as you need, within minutes.
All right, so hold on. Had to switch the video in the center. Okay, so basically what they're talking about here, waiting for the workday to end. Yeah. So basically, again, EC2 instance is not the EC2 instance. I'm sorry. The basics. You have your VPC, your virtual private cloud. So think of it as your own internal network, but you can also create different subnets to be in different availability zones or regions or geographical areas to provide a certain level of fault tolerance and protection against any type of failure. So that's actually highly recommended if you're using, if you're using it for critical applications. So again, you can build your VPC and have your EC2 instances across different availability zones. Again, think of it as of building your own virtual machine. You're just using someone else's computer to do it. So you can set up the region you want it to be in. Then you set up your Amazon machine image, which is essentially your operating system. So if you want to run like a Windows or Linux operating system, that would be Amazon machine image. Then you would also determine the size of your instance. So again, this is how much RAM, how much CPU usage, what your GPU usage is, and things like that. All right.
Amazon Elastic Block Store Overview. Amazon Elastic Block Store, Amazon EBS, is a service that provides block-level storage volumes for use with
And again,
Amazon
if y'all have
Elastic
any
Compute
questions for
Cloud,
me, man, like I said,
EC2,
you
instances.
don't have to just sit here and watch.
EBS volumes
talk while
behave
we're
like
doing
raw
this.
unformatted
A
block
lot of this
devices
is
in the
kind of
cloud.
just refresher.
You can mount EBS volumes as a
like I
device
said,
on your
I thought it
EC2
was pretty
instance.
cool that they have
Each
an
EBS
environment that's
volume
kind
can
of
be attached to only one instance at a time, but multiple volumes of
why
EBS
not?
can be on the same instance. Since EBS volumes are mounted to the instances, they can provide single-digit millisecond latency, which is extremely low latency between where the data is stored and where it might be used on the instance. EBS volumes are designed for both throughput and transaction-intensive workloads at any scale. Amazon EBS offers data persistence. All the data on the attached EBS volume remains available even after you stop or terminate an Amazon EC2 instance. Amazon EBS provides two major storage volume types, solid-state drive, or SSD-backed storage, and hard disk drive, or HDD-backed storage. SSD-backed storage is optimized for transactional workloads which involve frequent read-write operations with small I/O size. Some use case examples include databases and boot volumes. SSD-backed volumes include the highest performance provisioned IOPS SSD, IO2 and IO1, for latency-sensitive transactional workloads. General-purpose SSD volumes, GP3 and GP2, balance price and performance for a wide variety of transactional data. GP3 volumes enables customers to provision performance independent of storage capacity. The dominant performance for SSD-backed volumes depends primarily on IOPS. HDD-backed storage is for throughput-intensive workloads, such as MapReduce, data warehouse, and log processing. HDD-backed volumes include throughput-optimized HDD, ST1, for frequently accessed, throughput-intensive workloads. The lowest cost cold HDD, SC1, is for less frequently accessed data. Dominant performance for HDD-backed volumes depends primarily on throughput, measured in megabytes per second.
Okay. I mean, I think that's pretty self-explanatory. You would require solid state drive for high performance stuff, and then you would use your hard drive back storage for any type of stuff that's intensive on the throughput, as well as anything like cold storage. So again, we talked about cold storage, or like the Amazon Glacier feature the other day. That's when they talk about cold storage, they're referring to stuff that's not used or stuff that might not be accessed as frequently as other data, right? So you might have old pictures or old documents that you might need to save for personal reasons or even for professional or compliance purposes, but you don't plan on having to access them. So that's where you would use something like that, where you would use a solid state for things that have to, that need to basically have that high throughput and high availability. So this is like any type of financial applications you would probably use SSD drives for. Okay. And I didn't mean high throughput. I meant like transactions and stuff like that. Sorry. All right. So we talked about Elastic Block Store. Now it's overview. So now there's
Amazon Elastic Block Store, Amazon EBS features. Here are the key features. Amazon EBS Elastic Volumes. Elastic Volumes allows you to dynamically increase capacity, tune performance, and change volume types, with no downtime or performance impact. Simply create a volume with the capacity and performance needed today, knowing you have the ability to modify your volume configuration in the future, saving hours of planning cycles. By using Amazon Cloud Watch with AWS Lambda, you can automate volume changes to meet the changing needs of your applications. Amazon EBS Optimized Instances. You can launch certain EC2 instance types as EBS optimized instances. EBS optimized instances deliver dedicated throughput between Amazon EC2 and Amazon EBS, with options between 500 and 19,000 megabits per second, depending on the instance type used. The dedicated throughput minimizes contention between Amazon EBS I/O and other traffic from your EC2 instance, providing the best performance for your EBS volumes. Amazon EBS Snapshots. You can back up the data on your Amazon EBS volumes to Amazon S3 by taking point-in-time snapshots to enable disaster recovery. Snapshots are incremental backups, which means that only the blocks on the device that have changed are saved. You can create one or multiple new EBS volumes based on a snapshot and resize Amazon EBS volumes. The following are the key features for Amazon EBS snapshots. Direct read access. You can use EBS Direct API to read data off snapshots. This makes it easily track incremental changes between two EBS snapshots, without needing to create the EBS volumes in EC2 instances. You can create EBS snapshots from any block storage, regardless of where it resides, including data on premises. In addition, after a volume is created from EBS snapshots, your attached instance can have immediate access to the Amazon EBS volume data. If you enable Fast Snapshot Restore FSR capability, EBS volumes restored from FSR-enabled snapshots instantly receive their full performance. EBS snapshots can also be shared across AWS accounts and copied across AWS regions, enabling geographical expansion. In addition, when you delete a snapshot, only the data unique to that snapshot is removed. Data Lifecycle Manager for EBS snapshots provides a simple, automated way to back up data stored on EBS volumes by ensuring that EBS snapshots are created and deleted on a custom schedule. Snapshots are cleaned up regularly to keep costs under control. Simply tag your EBS volumes and start creating lifecycle policies for creation and management of backups. You can also use CloudWatch events to monitor your policies and ensure that your backups are being created successfully. With no additional fee, Amazon EBS Multi-Attach enables you to attach a single provisioned IOPS SSD, IO1 volume, to up to 16 Nitro-based EC2 instances within the same availability zone. Each attached instance has full read and write permission to the shared volume. Multi-attach makes it easier to achieve higher application availability for applications that manage storage consistency from multiple writers.
So that was a lot, but basically it's just kind of going into the different options that you have with your Elastic Block Store. So basically creating snapshots. Think of snapshots are backups. Yes, these are. This is from AWS's Cloud Quest video game, or they gamified it. So yeah. So you have the AWS snapshot. So this shows you how to create volumes and snapshots, which essentially are just backups. Okay, so snapshots are different backups. Yeah, I am a little tired, but you know what? We're here at the center. Like I said, I'm working through the day anyway, so we're just kind of we're gonna keep pushing. So we're gonna do a module a day, and then
Amazon Elastic Block Store,
just kind of
Amazon EBS benefits.
But yeah, no, I said I appreciate.
Here are the key benefits. Performance for any workload. EBS volumes are performant for your most demanding workloads, including mission-critical applications, such as SAP, Oracle, and Microsoft products. Relational and non-relational databases, enterprise applications, containerized applications, big data analytics engines, file systems, and media workflows are also widely deployed on Amazon EBS. You can choose from different volume types to balance optimal price and performance. Highly available and durable. Designed for mission-critical systems, EBS volumes are automatically replicated within an availability zone AZ and offer 99.999% availability. EBS offers a high durability volume, IO2, for customers that need 99.999% durability, especially for their business-critical applications. Since EBS volumes are for persistent data, it is important to back up the data. EBS snapshots with Amazon Lifecycle Manager, DLM, provides simple and robust backup solution to protect your data and can be used to enable disaster recovery. Cost-effective. EBS offers different volumes at various price points and performance benchmarks. Options range from highly cost-effective $ per gigabyte volumes to high-performance volumes with high IOPS and high throughput designed for mission-critical workloads. This enables you to optimize costs and invest in a precise level of storage for your application needs. Additionally, Amazon EBS snapshots are stored incrementally, which means you are billed only for the changed blocks stored, and save storage cost. Easy to use. Amazon EBS volumes are easy to create, use, encrypt, and protect. Elastic Volumes is a feature that allows you to easily adapt your storage volumes as the needs of your applications change. You can also easily create backups of your volume using EBS snapshots, and easily automate snapshot management using Data Lifecycle Manager, DLM, without any additional overhead or cost. Virtually unlimited scale. You can build applications that require as little as a single gigabytes of storage, or scale up to petabytes of data. All in just a few clicks. Snapshots can be used to quickly restore new volumes, enabling rapid scale. Secure. Access to Amazon EBS volumes is integrated with AWS Identity and Access Management, AWS IAM, which enables access control to your Amazon EBS volumes. EBS is built to be secure for data compliance. Newly created EBS volumes can be encrypted by default, with a single setting in your account. EBS volumes support encryption of data at rest, data in transit, and all volume backups. EBS encryption is supported by all volume types, includes built-in key management infrastructure, and has zero impact on performance.
All right, then let's let this.
Amazon Elastic Block Store, Amazon EBS, volume types. Let's compare the different EBS volume types. The general-purpose SSD volumes GP3 and GP2 are designed to offer single-digit millisecond latency. GP2 is designed to deliver a consistent baseline performance of 3 IOPS per gigabytes, and can burst up to 3,000 IOPS. It also provides a maximum of 16,000 IOPS per volume, and up to 250 megabytes per second of maximum throughput per volume. GP3 enables you to provision performance independent of storage. It delivers a baseline performance of 3,000 IOPS, and can scale up to 16,000 IOPS. And throughput up to 1,000 megabytes
Ty,
per second,
you
which
have
is 4
you have
times
the
more
option
throughput
to
than
encrypt your
GP2.
snapshots.
GP3 and
Backup.
GP2 have the same volume size of 1 gigabyte to 16 terabytes.
So it's the cloud, it's over
Next,
the internet.
let's look at the provision
Internet, you have
IOPS SSD
protection on
volumes,
it.
IO2, IO1. They are designed to deliver up to a maximum of 64,000 IOPS, 4 times more than GP3, and 1,000 megabytes per second of throughput per volume, along with single-digit millisecond latency. They have the same volume size of 4 gigabytes to 16 terabytes. However, IO2 is designed to provide 100 times more durability of 99.999% compared to that of IO1 and all other volume types. Customers that need sub-millisecond latency, or need to go beyond the current single volume peak performance and throughput, can use IO2 Block Express, which is designed to deliver 4 times higher IOPS, throughput, and capacity than IO2 volumes, along with a high durability as IO2. Now let's look at the throughput optimized HDD volumes. ST1 can burst up to 250 megabytes per second per terabyte, with a baseline throughput of 40 megabytes per second per terabyte. It offers a maximum throughput of 500 megabytes per second, and up to 500 IOPS per volume. Similar to ST1, Cold HDD SC1 provides a burst model. These volumes can burst up to 80 megabytes per second per terabyte, with a baseline throughput of 12 megabytes per second per terabyte, and a maximum throughput of 250 megabytes per second per volume. The maximum IOPS per volume for SC1 is 250 IOPS. Both SC1 and ST1 have the same volume size of 500 gigabytes to 16 terabytes. As you can see, Amazon EBS provides all these different volume types, so that you can tailor your storage performance and cost to the needs of your applications.
So you might want to, well, if you intend on doing AWS training or building different environments, this would definitely be a good thing to know. So again, you know what you have to do, or for different purposes. So, for example, you want to make sure if you're doing stuff like transactional, you want to make sure you're using SSD. If you want to make sure you're doing stuff with optimized throughput, you want to make sure you're using these options here. So you want to make sure you're using the right the right drive.
Hello,
right,
and welcome to AWS Well Architected Overview.
hard drive.
AWS Well Architected helps cloud architects design infrastructure that is built around 6 pillars: operational excellence, security, reliability, performance efficiency, cost optimization, and sustainability. The AWS Well-Architected Framework includes hands-on labs, access to the AWS Well-Architected Partner Program, and the AWS Well-Architected
I
Tool,
want to say
which architects can use to evaluate workloads, identify high-risk issues, and record improvements.
but we'll watch it again.
Let us take a closer look at the 6 pillars that define an AWS well-architected design. The operational excellence pillar focuses on running and monitoring systems and continually improving processes and procedures. The security pillar focuses on protecting information and systems. The reliability pillar focuses on ensuring workloads perform their assigned functions and recovering quickly from any failure to meet demands. The performance efficiency pillar focuses on selecting suitable resource types and sizes, monitoring performance, and maintaining efficiency. The cost optimization pillar focuses on understanding spending trends, controlling fund allocation, and scaling to meet business needs without overspending. The sustainability pillar focuses on minimizing the environmental impact of running your cloud workloads, such as energy consumption and resource use. How does the AWS Well-Architected tool help create a well-architected infrastructure? The AWS Well-Architected tool extends the well-architected functionality, best practices, measurements, and learnings into your existing architecture processes, applications,
we're going to get to the
and
hands-on
workflows.
stuff after this video.
It creates custom lenses
I believe
where you
so.
can add best practices pillars and questions based on what's most important to your organization. Using the tool, you can share your workloads and custom lenses with up to 300 individual AWS identity and access management, or IAM, users or accounts, or across an entire organization. Reviewing your workload against sustainability best practices in the AWS Well-Architected tool can help you understand energy consumption and environmental impact. The AWS Well-Architected tool is available in the AWS GovCloud region of the US, so customers with specific regulatory and compliance requirements can conduct self-service public sector reviews. You can learn more about the AWS Well-Architected tool and custom lenses by visiting the AWS Well-Architected website.
All right. So, yeah, so like I said, so we covered that. I'm going to go ahead and mute that now so we don't get any copyright hits. Turn this back up if y'all want to hear some music. All right, so we talked about the AWS Global Infrastructure. We talked about EC2 overviews. We did the benefit video, and then we also did all 4 of those. Okay, so we're good. So we covered that. All right, so we can get to the hands-on stuff. All right, so now we're going to go ahead and move into our planning phase, which is our practice labs. So we're going to launch the EC2 instance, and we're going to configure the user data script to display the instance details in the browser. And then after that, we're going to launch a second one, a second EC2 instance in a different availability zone of the same AWS region. Okay. So again, we're going to focus here. We're going to launch an EC2 instance in US East 1A, and we're going to configure the user data script to display the details of the instance in our browser. Okay, so let's go ahead and start that up. So we'll hit practice. So we have our steps here. We're going to start our lab, and that should open up a console over here. We're going to share this tab here for the console, and I'll do the walk. I'll walk through the different things of what we're doing. So first, again, we want to make sure that we are using the AWS lab and not our own AWS account, which again, I said was kind of smart because people were doing their labs or building their AWS environments and leaving them on and then getting hit with a high bill. So I'm glad they have this here now. So now for the lab files, it looks like we need to, looks like we have to download the user data. All right, so it says we're going to review the practice lab objectives in the concept section below. We're going to start the lab, follow the instructions, okay? AWS services, okay? So we did that already. So we're going ahead, we start the lab, we click the lab file, and we just, I'm back over here reading this real quick. So I went ahead and I downloaded the lab files just so you know what's going on. So we downloaded the lab files, and it says click the steps tab to return to the practice lab steps. Okay, which we did. Fantastic. Now we'll move forward. Okay. So now in the navigation bar, it says make sure we are set to our North Virginia region, which we are. You see that here. We're in the North Virginia region, and it says US East 1. Yep, North Virginia, US East 1. So we're good. Just clicked it just to be on the safe side. Okay, now we're going to go ahead, just like the other day when we searched for S3, we're going to search for EC2. And we're going to click this option here. So that should bring us to the EC2 console. And now we're going to go into our dashboard and launch an instance. So we need to find, we are in the dashboard, right? Yep, we're in our dashboard. Yep, we're here. And then once we're in the thing, we're going to hit launch instance. All right. So we launched our instance, and we're going to name this one. We're going to call it Web Server 01. So we're going to give it a tag. And then in the AMI section, or the application operating system image section, we are going to choose Amazon Linux. Okay, so we have that. No, I said Amazon Linux, sorry, not Mac OS. So we gave it an Amazon Linux image. Okay, now we need to scroll down to the AMI section. Amazon machine image. Did I scroll past it? So application and no, we did do that already. All right, cool. All right. So we click the Amazon machine image, and then we're going to choose the Linux 2 AMI. So this is Linux 2023 AMI. It says Linux 2 AMI. So that's that one. It's a SSD volume type, 64-bit architecture. Okay. And we need to make sure we are using the T2 Micro, which is here, free tier available. So again, when dealing with AWS, you do have some free tier options. They're not the best if you plan on doing any type of heavy lifting, but again, it's a great opportunity to kind of mess around with it and learn how to do it before you start having to pay for AWS usage. So now we need to scroll down and find where it says keep here login, which we do have it right here. So it says keep here. Okay. And now we're going to choose to go without a key pair. So proceed without a key pair. You see it's not recommended. Again, you always want to make sure you're creating secure instances so that people don't find ways to gain access to your stuff. And then we're going to edit the network settings. One second, y'all. I want to check something. Oh, that was weird. Okay. So now we chose to proceed without it, and now we're editing the network settings. For the VPC, we are going to select the Cloud First Steps Lab VPC. And then for the subnet, we are going to use US East 1A. Okay, here we go. It took me a second to find it. So that's 1B. So we're going to pick US East 1A. Okay. All right. So again, we created a VPC, which is just the virtual network. Okay. So that's and then the US East is the region. All right. So now we're going to go into our security settings, network settings, keep here, login, configure storage. Isn't it advanced? Nope, that's domain information. Let's scroll back up. Keep here, instance. Did I? Keep here. Subnet. Fire. Here we go. Security group. I went right past it. All right. So security group. We're going to type in security group lab. So we're going to call this security group lab. All right. So we have it there. And then for the description, we're going to call it an HTTP security group. So HTTP security group. I am hungry. What did I eat today? For type, we're going to choose HTTP, so not SSH. And then we're going to go down to the configure storage. And for our root storage, we are going to pick GP2, which it is already set to GP2. Looks like it's 8 gigs for GP2. And then we are going to open up our advanced details. So I jumped ahead a little bit before. And then once we open up our advanced details, we're going to use that file that we just downloaded. Okay, so we have our advanced details. So I'm going to give me 1 second to share. I'm trying to see if I'm trying to share that to show you the user data information. So create a new directory, IAM, DNS requests, instance recovery, purchasing options. Okay. Open the data file that you downloaded and review the content. The user data script launches a web server using port 80. The code, all right. Okay. All right. So real quick, I'm just going to show you what it looks like. If it'll let me. Sorry, y'all. All right. So real quick, you'll just see that we are observing the user data information. Give me 1 second here. And all it's telling us is that it's going to launch a web server. So we have our URL information here. So you see there's a curl command to put an API token with the so you have a put command. Looks like it's going to push to the API token, the meta token with that time limit. So again, that's just kind of push it. That's just the different information that's going to run through the curl commands. And then you see we just scroll through here. So basically, like I said, it's just a script. Okay. And then it'll, like I said, and when it's running, it'll when we go to access that website on port 80, you should see something that says your EC2 instance is running. Okay. So that's all it is. It's just a HTML script. All right. So we'll go ahead and we'll close that. And we will now go back to stop sharing, and we will go back to our instance here, or what we're doing, our exercise. All right, cool. So we're back here. So now we just need to go and choose our user data folder, and we will do that. We have all of that there. So that basically that same script that we were just looking at. Okay. And now, again, we just need to review everything to make sure that it's good to go. Again, like I said, it's going to export an token using the curl command to this IP address. And when it uploads successfully, you'll know because it'll tell you that it's running. All right. Hey, what's going on, Monica? How you doing? Hope all is well. We're just doing some AWS refresher stuff. Had some downtime from teaching, so figured I would take advantage of the opportunity to, I guess, teach a little bit more. So once we have everything reviewed, we'll go ahead and we'll click launch instance. So now we're going to let that load up for a second, and then we should get the successfully initiated launch, which we did. So now if we scroll to the bottom, okay, we're good to go, and we can click view all instances. So now you'll see we have our web server. And if we click the web server, you'll see that it says it's running. And we want to check it to bring up the details. So again, you see that it says it's running. Here's our IP address. And we'll just go ahead and click this here. Off subject, do I deal with imposter syndrome? All the time. All the freaking time, and all the time. We'll touch on that in 1 second. I want to make sure that everything is running properly, which it is not. Interesting. Display state. So we click that. It says do not use the open address link. Oh, that's why I did that wrong. I did something wrong. My fault, y'all. In a new browser, DNS. All right, my fault. So that was my fault. Now let's give me 1 second. There we go. So I jumped ahead and didn't do what I was supposed to do. That's why you should read all the instructions first. But now you see we have our stuff. So we are now done. So I'm going to stop sharing real quick. And then before we go into the practical, yes, let's go ahead and answer that question. Do I deal with imposter syndrome? Yes. It's something that I think a lot of us go through, especially in this field, being cybersecurity experts, not experts, but being cybersecurity professionals. Yeah, there is a lot of imposter syndrome going on because you see other people doing great things, right? I work with a bunch of brilliant people, and I'm friends with a bunch of brilliant people. I personally know a bunch of brilliant people. So yeah, you'll have those times where you feel like you may not belong, or you feel like you're not good enough, but you're in the room for a reason, right? That's how I look at it. You're in the room for a reason, as well as you earned your spot there. So take time to give yourself the grace and pat yourself on the back, because regardless of your level of success compared to others, you still have a certain level of success, and you also um, have achieved a level of success that some others haven't. So it's something that you have to deal with. It's something that you need to have patience with yourself. Stop comparing yourself to others. And I tell myself that all the time as well. Honestly, I think the crazy part is I've dealt with more imposter syndrome in the last 18 months than I think I've had in my entire tech and cybersecurity career. Reason being is there was a lot of different things that happened to me personally, professionally, um, that had me feeling like things were off, right? I had health issues, all of that, still dealing with, you know, brain fog and certain things like that. You know, layoffs, all of that, and then on top of it, I opened up I opened up a center, or I opened up a esports and technology center, and started to learn a completely different space. Tech and cybersecurity, yes, they run very parallel to each. I'm sorry, tech, cybersecurity, and gaming. They do have some parallels, but they don't also have their own challenges that are independent of each other. So yeah, you do. I deal with imposter syndrome just from the tech side, the cybersecurity side, and I also deal with imposter syndrome working along my new peers that I've met in those relationships in the gaming and esports space. I have imposter syndrome when dealing with other people who are instructors now that I'm teaching more. So again, it's just a matter of being patient with yourself and sticking to the code. Things don't happen overnight. Um, and you're gonna fail. Honestly, if you're not failing, if you're not failing, especially in this field, you're not trying. And like I think, yes, I know that sounds cliche, but it's true in this field, especially if you're in the offensive security side of cybersecurity. If you're not failing, that means you're not testing the limits. You're not testing that curiosity. You know, I think of when I work on certain pen tests, and everything looks secure, but you're trying to find different ways. You're trying to find a way to trick the API. You're trying to find a way to trick the AI now, right? The chat GPT. You're trying to find ways to trick the LLM model, right? So you've got to keep trying, and you got to stay focused, and like I said, just keep at it. All right. So sorry, that was I hope that answered your question. So back to it. We are going to now it says for our challenge, we need to open up our AWS console again. So I'm gonna go ahead and share that. And now we need to make sure, yeah, the process is slow, but keep on. Yeah, you have to. Again, I mean the process is what you make it, right? The process is what you make it. You can't measure your learning your learning style to someone else's. Some people are visual, some people are hands-on, some people can just watch a video and fully get it at photographic memory. So whatever, you have to figure out what method or methods work for you, right? I'm a visual person, but I also need that hands on. And sometimes I need to do stuff hands on multiple times, right? Like I talk about it all the time. Um, Dealing with, especially with cloud, right? Dealing in application security, like I'm pretty much good with every other type of attack vector. I hate server side request forgery attacks. I struggle with those attacks. And it took me a while just to even fully understand how the attack worked before, you know, before I fully, before I got it. It took me a while to really figure it out. So, and the funny thing was, what helped me better understand it was that I needed to start teaching it because it became a new attack vector, or it became a more popular attack vector for APIs, right? So when dealing with the API security top 10, the first top 10 list didn't have server side request forgery. The second one did, and I was like, oh crap. And then I had to literally sit there and break it down. I had to draw up the chart and everything, and then just go through it and just drill through the Try Hack Me labs, Pen Tester lab, all the different resources until I fully understood it. I asked other people. Shout out to BSD Bandit, Charles Scherer, right? He was a mentor and a great resource to so many people. And on top of it, he's just a genuine solid dude. So, he also helped me better understand it. So, again, you gotta just be patient. Just be patient and stick with it. Like it's just not gonna happen overnight. No problem. All right, so we opened up our console, and now we're going to launch a second EC2 instance in a different availability zone of the same region. Okay, so a different availability zone in the same region. Okay, so we need to go to our instances. No, okay, let's go back to let's double check this. Okay, so we're launching a second one. So we're actually creating a second one. All right, so I need to go ahead with these files. So we'll go ahead and do this. I'm just thinking, second instance, different availability zone, same region. I want to make sure I fully understand that. Why does it sound like something is? Oh crap! 1 second, y'all. If it's not one thing, it is another. All right. Sorry about that, y'all. That sucks. Okay. Give me 1 second. I just got thrown off. I kept hearing like a tapping, and it looks like there's something leaking. So I have to respond to that in 1 second. Okay. Jeez. All right, I'm gonna wrap up this stream and then I have to go deal with this leak. So so we're gonna go ahead. We are here. We're gonna go ahead and launch an instance. We're gonna call it web server 2. Again, we're gonna follow the same steps as before. So we're gonna use the Amazon Linux. We're using the free tier Amazon Linux 2. Okay, we're going to keep the same architecture. We're going to make sure we're using the same T2 micro. We're going to go ahead and proceed without a key pair. We're going to create the security group. Again, what did we do for security group last time? What did we do last time, y'all? If y'all remember, we created the key. We did the key pair, no key pair. We went to the network settings, right? Is that what we did? Yeah, let's go ahead and edit that. And we'll do the lab here, the subnet. We want to make sure that it's in the same availability zone. No, different availability zone, same VPC, right? Is that what it was last time? That's what they said, right? Right? Different availability zone of the same region. So a different availability zone of the same region. US East 1B, US East 1A. So different availability zone of the same region. Yep. So that's it right there. Cool. Right. And now for our security group is HTTP. We want to go and configure our storage. It is the same thing, the GP2, free tier, great. Okay, we don't need to add a new volume. We need to go to our advanced settings. And then after we go to our advanced settings, we need to upload do I need think now actually think about it. Do I need to do another is it the same user data file? I don't know. Well, let's just download a new one. Make sure. All right, so that looks good. Oh, that pisses me off. Jeez. Sorry if I'm rushing. Like I said, I just wanted to kind of get through the steps, and then, like I said, I got to deal with whatever is going on over here in this corner. Oh, start a business and get a space. They said it'll be fun. They said. All right, so we'll go ahead and launch the instance. Oh my gosh. All right, so now we'll go back to our instances. We should have 2 instances now, right? Yep, web server 1 and web server 2. This one is pending. All right, so they're both running now. Cool. So now we want to double check to make sure that it's running like we did before. We're gonna get the DNS name for it. Let it load. And it's not working. Why are you not working? Why are you not working? I need you to work, please. And yep, there it goes. It just took a second. So now we're working. Now we're good. All right, so we are back on track. So we can go back here. We'll share this. Yeah, like I said, no problem, Monica. Like I said, this is the second day, so we're gonna do the series of the entire course. All right, so now to verify that we did it properly, we need to name the instances in AZ1 and AZ2. So the instance ID for here, we're going to, so AZ1, we need to do that. Give me a break. All right, so give me the instance ID. We're going to share back over here. So AZ1, this was our instance ID. And then in AZ2, we'll come back and we will copy that here. And we will come back here. And then in AZ2, we will do that. And then we will click validate. Boom. All right. So we have created our instances in the correct availability zones. We validated it and we are good to go. So we can go ahead. We're going to hit exit and we are going to go back to our person. Says the island is safe again. Okay, and the mayor wants to give us a present and they're going to build a private island. So we have the lighthouse, and now we need to build our own private island. What do we want it to look like? I'm feeling option 3, y'all. We built the lighthouse. I'm feeling option 3. It's giving me, it's kind of giving off the vibe like a fortress. It got the little gate here. I mean, I know it's a different type of game, but I think I'm going to go with option 3. I mean, option 1 is cool. Nice little house. Option 2, but like I said, option 3, I like. I'm feeling option 3. All right, so let's see. We got to vote for option 1. Let's see. Option 1 looks like a palace. Yeah, I guess. All right, fine. We'll go with option 1, even though I think option 3 kind of gives me like whatever. But we'll go with option 1. All right. So now we have our private island. We have our lighthouse that we built earlier. Now it says the neighborhood is at level 2. So now we have buildings and customizations available. And now we can unlock pet friends. So now we can find pets and then answer quiz questions. Okay, so again, that's another way to kind of reinforce your learning. Use the XR device to visit your home. And again, we now have 50 gems. We have 8 more customization options, and we have more reputation points. We'll give it a 5 for stars. Now let's see. So we can go to our player island, right? So let's get in our little hoverboard.
See all the healthcare things. Visit kp.org/all care can be.
Okay, so now we can customize, right? So we have 150 points. Oh, damn. Nah, we're good. We're good. We're good. I don't want to buy it. I want to do all that right now. All right. Okay, so we got our stuff. Let's see. Now it says there's some pets. So okay, so we have to move around the map to find the pets. Do they have a wolf? Yep, they got a wolf. Bet. All right. I gotta do the wolf. I gotta have the wolf representing for the center. All right, so let's see where we're at. All right, so I think we are done for today. Let's just do a quick drone view. Can we move around in the drone view? These are all customizable. It looks like our next mission is over here for computing solutions. I'm cheating a little bit to see if I can find any of the pets. Oh, this is locked over here. Okay. So again, like I said, you see, it kind of gives us this little interactive world to deal with. So as we progress, so again, it's cool because again, as you go through the game, you get more stuff, you progress through it. So I mean, like I said, it's cool. It's a cool concept. No, I don't want to purchase anything just yet. All right, so we are, like I said, so we're all done for the day. I'm gonna go ahead and log out. And that is it, y'all. So like I said, we're just under 2 hours, but we're actually about an hour and a half. So we're gonna go ahead and wrap up unless anybody has any questions for me. Funny thing is as I was looking, as we were playing some of the videos and stuff, I really started looking at this that GeForce now because I just think it's a cool option. So looks like you still have to have your own game library, right? So you still have to have your own game library, but then you can choose your device, and then you can access your setup from a web browser. I think that's pretty cool. Like I said, you just have to have good internet. And the reason why I think is because, you know what? I think gaming should be accessible to people. But a lot of people can't afford gaming PCs. I think this is. I have so many ideas that are just kind of popping through my head right now. I have to think this through a little bit. Do I have any new merch? Um, well, I'm wearing my Only Hacks T-shirt on my my T Public store. But as far as new merch, I have jerseys and stuff like that. Um, for the esports center. Let's see if I can bring them up here. So I do have like some jerseys. Like for example, you have jerseys here. Then you have this one. This is a different jersey. I'm actually in the process of designing a new jersey. And then you have like some crew neck T-shirts. I know it's summertime, but we have this windbreaker hoodie and a couple other things. So that's pretty much it for merch at the moment. Um, and like I said, you can make your own jersey. You can customize it. Have you put your name on the back and stuff. So we have that stuff for our esports stuff, and then our other merch we have at our T Public store. I don't even remember the link. That's crazy. Is it T-Jax? Crazy thing is, where is my? Give me 1 second. Where we at? I said it's been so long since I've like now it's like all my merch stuff got pushed to the back. So T Public, like I used to do a lot on T Public, and then when they messed up my my hackers design, it kind of turned me off. I gotta stop being so petty. But anyway, yeah, like I said, you have different stuff here. Let me stop sharing. I'm still sharing the thing. Well, like I said, we have different apparel, different jerseys, stuff like that, and then our T Public store. I'll try to find the link for that. Like I said, I'm on the wrong. I'm on my other PC, so take that down. So give me 1 second here. Beep, 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 beep. Where is my stuff? I was just over here the other day. Um. Did they take down my Only Hacks design? So anyway, like I said, I'll put up the link. But like I said, I have my if you can see it, it says only hacks. So we were doing when we were doing our play on OnlyFans during the pandemic when everybody was signing up for OnlyFans. So we had our only hack stuff, and then we were gonna do another one that was like, no feet. But anyway, I don't want to keep y'all too much longer. Thank you for checking out the stream today. Again, we are going to go through the AWS Cloud Quest game and learn more about AWS Cloud. So I will see y'all. I'm thinking, let's see, what's tomorrow? I do have another class I'm teaching tomorrow. So can you get what in black or gray? I'm not sure which one you're looking at. But yeah, like I said, I will let y'all know the next time I'm gonna go live. Hold on. Oh, the only hack shirt. Yeah, I think so. If I could even find the T Public page, as like, hold on. I said, I've been out the game for so long, man. And the crazy thing is, only been. I mean, I'm not really out the game, but I've just kind of been so out of the loop, just kind of getting everything together. It's just, I don't know. I just saw something that was interesting as I'm scrolling. Okay, so here we go. Okay. All right. I'm sorry. Now let me bring. I think I found it now. So I was doing that. User. There we go. All right. So yes. So here is my T Public page, which has a few of my old designs on here. But like I said, I have my Alpha Esports and Technology T-shirts here. But then I also have the stuff for my Alpha Cybersecurity, my InfoSec Twitter veteran. If you know, you know. Then I have my Only Hacks, some and some other designs that we have. I had a really cool hackers one that was kind of like played off of the Friends logo, but they didn't like that. And then I had another one. I had another really cool one that was like almost like Legend of Zelda, but Nintendo they didn't like that so much. But anyway, like I said, so go ahead and again like this, like the channel, like wherever it is you're watching. Leave comments, click the bell for notifications to be notified when I go live again. And I will see y'all, like I said, if I don't, maybe not tomorrow, but I will probably Friday. So, like I said, I'm going to try to get through this as much as possible. So y'all go ahead, have a great night. It's almost 7 o'clock. Go get some dinner, get some rest, and I will see y'all Friday. All right? Peace out.